Kia ora, and welcome to this presentation, which is part of the BERA British Curriculum Forum event, titled Researching Curriculum Subjects, Understanding How Teachers Plan, Design, and Lead the Curriculum. This presentation is about the Curriculum Design Coherence Model, or CDC model, currently being designed and developed in New Zealand and trialled in both England and New Zealand. This presentation comprises an elaboration of the CDC model's use in the subject of music. It may be advisable to listen to the overview of the CDC model provided on this website by Professor Elizabeth Rata before listening to this one. My presentation is designed as a complement to hers, as I will spend less time introducing the elements of the model and more time on demonstrating how the model can be put to use in a specific topic. But first, a couple of points to create a context for the model's development. For quite different reasons and in very different contexts, teachers in both New Zealand and the UK are now not only required to be teachers, but also curriculum designers or curriculum makers. The fascinating differences in the two contexts is a talk for another time, but teachers in both jurisdictions are now expected to rise to the challenges involved in curriculum design. The CDC model is a response to these challenges and also to some unintended consequences of a number of major policy and practice changes, both New Zealand specific and international, that have occurred over the last 30 years. In relation to New Zealand specifically, I want to draw your attention to our non-prescriptive, generic, outcomes-based national curriculum that emphasises skills and competencies at the expense of identified subject knowledge. The second key point concerns the secondary school. We have a modularised, outcomes-based assessment system that tends to fragment the curriculum and undermine subject conceptual coherence. The model is a response to both these problems. In response to the first problem of lack of guidance about what to teach, because the curriculum is so generic, the model adopts an approach that places what is to be learned at the centre of the design process. What includes subject concepts and content, what in the model we call knowledge that, and what also includes subject skills and competencies, what in the model we call know-how to. In response to the second problem of fragmentation, coherence is reinstated as subject concepts provide the linking mechanism within and across the topics chosen to be taught in the subject program. The model aims for coherence to enable deep learning by placing concepts at the centre of the topic design process. So the CDC model is based on the proposition that deep learning comes from access to epistemically or conceptually structured systems of meaning, disciplines or parts of disciplines, recontextualized as school subjects, that enhances the development of human cognitive architecture. Coming into contact with these conceptually structured systems of meanings, we argue, helps the development of students' cognitive architecture. The second key point is that deep learning comes from the marriage of knowledge that with know-how to. Without each, the other is a serious limitation for learning. The model resolves this problem by placing subject concepts at the centre of the design process. Subject concepts act as the cohering mechanism in the model as conceptual knowledge, knowledge that, and procedural knowledge, know-how to, are brought together, linked to content, and then evaluated in both relation to what students know and what they can do. Without knowledge that, without know-how to, is abstract academicism, And know how to, without knowledge that, is mindless technicism. So we propose that the model provides a means to develop curriculum design at a deep level. And it aims for coherence between four key components of design: subject concepts, subject content, subject skills and competencies, and evaluation. So how does the model achieve this? Well, we propose that the model provides a means to develop curriculum design at a deep level by drawing on a theory of knowledge. And in particular, three key design principles are drawn on. The first is the concept of epistemic structure, and this refers to the way a subject or topic is structured as a series of interrelated concepts: a conceptual structure, an epistemic structure, or what we also call a system of meaning. The knowledge that, know-how to, distinction and connection is the second and third of the design principles drawn on from the theory of knowledge. And this refers to the way that the two forms of epistemic knowledge, knowledge that and know-how to, first need to be differentiated for design in elements 1 and 2, and then connected in design in element 3. So our key proposition is that deep learning comes from the coherence provided by making the epistemic structure and the interrelationship between knowledge that and know-how to the basis of design. It is important to note that the model is a design tool. Matters of delivery of pedagogy are implied by the design, but the conceptual design is not the same as the design required for delivery. Research about what optimal pedagogies are implied by design will comprise a second part of the research project. Now onto the model and its use in the subject of music. So element 1 says select and sequence the subject concepts from a subject topic proposition. And this element requires that the teacher begins a toing and froing process to bring to the surface the key subject concepts that are inherent in the chosen topic, and to enable the development of an overriding topic proposition. The proposition should encapsulate the key concepts of the topic, and the proposition statement, although it may not emerge first, is the fulcrum for the design. The proposition connects the key subject concepts to the topic, thereby beginning the process of design coherence. Superordinate concepts and inferred subordinate concepts then appear in all the elements of the design, providing coherence. The proposition and its concepts also provide the foundation for the selection of content in element 2. So here is a proposition for the music topic, composing a blues. It contains the key concepts that will comprise the knowledge that required for a student to compose a blues. The blues is a musical form generated from a particular combination of text, harmony, melody, timbre, and expression. It's a reasonably abstract proposition. The second step in element 1 is to determine the inferred relationships between these concepts. The design must make visible the interconnections and possible hierarchical structure of the concepts within the topic. For example, for this topic, blues songwriting, I have chosen form as the superordinate concept, since without form we have no song. And the related concepts I've chosen are text, harmony, melody, timbre, and expression. The conventions for combining these elements creates the particular style and form and indicates the subordinate concepts required for learning. For example, subordinate to text is the concept stanza. Subordinate to harmony is the concept chord progression. Subordinate to melody is the concept of scale. Subordinate to timbre and expression is the concept of instrumentation, and so on. Now, there are potentially varied conceptual mappings possible for a topic, depending on the angle being taken. For example, here the key outcome is to compose, but the blues could also be studied from a socio-cultural and historical perspective. The concepts chosen in that instance are likely to be slightly different. So this is the initial epistemic mapping for the topic, composing the blues. An initial superordinate concept form and 3 subordinate concepts and a number of inferred related concepts. On to element 2. Connect subject concepts to subject content. The second element establishes the significant distinction between subject concepts and subject content, and the connection between them. The content is the materialization of each of the subject concepts identified in element 1. Without the content, the concept remains abstract. Concepts are made material by the content. An example of this is when the concept chord progression is connected to content that best initiates students into understanding its properties. In the case of this topic, chord progression becomes a particular 12-bar blues chord progression. It is important to note that content is not merely lists of facts and information, but carefully chosen material that elaborates the concepts, materializes them, and in this case, in sonic and somatic form. Traditional lesson design tends to start with content, but subject concepts provide the means for connecting content to a deeper level of meaning. So the argument here is that epistemic structure should be the generative mechanism for design, concepts and their interrelationships. We have developed 3 justifying criteria for choosing content. The first criterion is epistemic. It's the primary criterion. The teacher needs to ask which content best exemplifies and elaborates the meaning of the concepts. Is the content apposite for elaborating the particular qualities of the concept to be studied? The second criterion is also epistemic, but concerns socio-epistemic nature of epistemic knowledge, the context in which concepts develop. The teacher includes content to show that ideas and concepts, in this case the blues, are always provisional and subject to challenge and change because they are created and critiqued by people in academic and practice communities. Understanding that concepts and theories are always provisional helps students to understand the difference between beliefs, which tend to be fixed, and the dynamic nature of epistemic concepts and theories. The third criterion for content selection is socio-political. The teacher asks, is this knowledge that we as a society want the next generation of citizens to know? How will the students benefit from acquiring this knowledge? The examples of blues chosen in element 2 illustrate how the genre has changed over time and how it has influenced and helped to generate other styles of music. Criterions 2 and 3 may not always be required or relevant. It will depend on the subject and the topic. Here is some content chosen to best represent the concepts for the topic. A number of examples of blues that students will listen to orally and through which they will become familiar with the key characteristics of the blues outlined in the concept mapping. From early to later blues, blues sung by women, sung by men, and spanning the period 1928 through to 2004 and beyond. Also part of the content will be further subordinate concepts that materialize both orally and in the body, concepts as learning activities. Chord progressions, blues scales and riffs, syncopation, call and response, rhyme and word setting. All of this content best materializes and represents the key concepts as mapped in element 1. On to element 3. How will we actually connect knowledge that to know how to? Crucially, the purpose in connecting knowledge that and know how to is to make the connection between generalizable concepts to a range of specific instances where the concept can be applied and made real. This moves the student beyond only being able to either identify and describe, as in the case of knowledge that, or only being able to know how to do something, as in the case of know how to, towards combining both forms of knowledge, leading to deeper learning. This element focuses on two competencies within know how to: performance competencies and judgment competencies. Performance competencies, not necessarily related to music performing, refers to the techniques and skills used to apply conventions in practice and to students' degree of performance mastery. These competencies can be abstract, as in the analysis of a piece of music, or procedural, as in the performance of a piece of music. Secondly, we have judgment competencies, and these refer to students' ability to judge the effectiveness of the solutions and their understanding. Judgment competencies require students to know why something is the case, what we call intelligent knowing why. For example, the student uses the correct chords in their chosen key for the blues. Judgment competencies require students to know why something is the case and to be able to explain it, and ideally to write about it. Here are some examples of performance competencies and judgment competencies that connect knowledge that with know how to. For example, in the performance competencies, a student knows how to already recognize chord changes in harmonic rhythm. A student knows how to play a blues scale in C major. A student knows how to include appropriate blues figures into their tune, and so on. For judgment competencies, a student knows how to recognize if their chord progression is actually correct. They know how to recognize using blues figures that sound authentic melodically. They know how to recognize if the call and response structure is in the correct place, and so on. Element 4. Evaluate knowledge that and know how to. Lying at the heart of evaluation or assessment is the student's developing ability to make judgments through demonstrating intelligent know how to and knowing why. This is the deep learning the model aims for. It requires the integration of knowledge that and know how to. Concepts are the means to make this integration. The evaluation system includes assessment of 3 types of competency. Content recall is important as content creates our long-term memory banks by providing the raw material for conceptual understanding. Content is the fuel that eventually drives the development of higher order thinking. To enable this, students need to know a great deal of content, for example, how scale patterns work, what the scale pattern is, key signatures, chord sequences, facts about many blues pieces and musicians. This competency also assesses a student's use of the correct vocabulary used in all the elements. The second competency, skills and technique, concerns the level of mastery of the skills and techniques needed to demonstrate understanding of concepts and memorization and utilization of content. For example, did the student use the correct chords and sequence of chords in their blues? Did they create dissonance in the use of a blues scale against the unchanged harmony? Did their chosen text fit within the chosen meter? The final competency, intelligent knowing how, is the most important in that it includes students knowing which formula to select or understanding to apply, which skills and techniques to use, in which context or situation, and judging whether these selections produce the desired quality. Moreover, this competency requires students to be able to use subject concepts to explain and justify their choices and the outcomes. This is the level of judgment competencies referred to in element 3. Each competency requires responses at increasingly higher order or abstract cognitive levels. For example, from unistructural responses for content recall through to extended abstract responses for intelligent knowing how. Here are some examples of evaluation questions or activities. Content recall. Students can describe the major scale pattern using the related concept of intervals. Students can name the chords in a standard 12-bar blues progression using Roman numerals and specific chord names. For skills and techniques, students can play these particular things. For intelligent know-how too, students can explain how they have used musical elements and features to create the blues. For example, explaining how they've created dissonance, explaining how they've created call and response, and explaining in what ways their blues is typical of early blues forms. Well, so what, you might ask? On the surface, if you came to my classroom and you had also observed another teacher teaching the blues, you might not notice anything markedly different. But I argue that the model provides the means for thinking more deeply about what is to be taught, and the conceptual mapping provides an overview from which subsequent pedagogical decisions can be made. The model provides cohesion by linking subject concepts to content, skills and competencies, and evaluation. The model makes the design process explicit and cohesive and provides a way to see the subject with new eyes. So, in this presentation, I've discussed some recent research in the area of curriculum design using a model developed at the University of Auckland. The model aims for coherence to enable deep learning by placing subject concepts at the center of the topic design process. Subject concepts act as the cohering mechanism as knowledge that and know-how to are brought together, linked to content, and then assessed. The focus of the New Zealand curriculum and the senior school NCEA assessment system on outcomes or know-how to provide few indications of the knowledge that required to build conceptual understanding. The CDC model makes visible what is required for deep learning, that is, learning that is not bound to one context or bound to know-how to, but learning that empowers students to be able to think beyond the present and particular. Thank you for listening to the presentation, and please email me or Elizabeth Rata if you have any questions about the model.